Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. Have you ever wondered why you can't unscramble an egg? Or why a shattered glass never spontaneously leaps back onto the table, perfectly whole? We usually point to entropy, the universe's tendency toward disorder, as the reason. But there might be a more fundamental, almost invisible reason why the past stays behind us, and it's hidden in the very shape of the molecules that make up your body. This is the mystery of chirality and its connection to the arrow of time. In chemistry and physics, chirality refers to handedness. Think about your hands. Your left hand and your right hand are mirror images of each other. But no matter how you rotate them, they can never be perfectly superimposed. You can't put a left-handed glove on your right hand and have it fit correctly. This simple concept of left and right exists at the molecular level too. Many of the most important molecules for life, like amino acids and sugars, come in two versions, L form and D form. Curiously, almost all life on Earth uses left-handed amino acids and right-handed sugars. This is known as homochirality. But what does this have to do with the flow of time? To understand that, we have to look at the fundamental laws of physics. For a long time, scientists believed in something called symmetry. They thought that if you swapped every particle for its antiparticle, or if you mirrored the entire universe, the laws of physics would still work exactly the same way. This is known as parity. Furthermore, they believed in time reversal symmetry. This means that if you reversed the direction of every particle's motion, it would be like playing a movie backward. The physics would still hold up perfectly. In the world of Newton and Einstein, the equations don't really care if time goes forward or backward. However, in the 1950s, a physicist named Qian-Xiang Wu conducted a groundbreaking experiment that shocked the scientific community. She discovered that the weak nuclear force, one of the four fundamental forces of nature, actually distinguishes between left and right. During the beta decay of cobalt-60 atoms, electrons were emitted in a preferred direction. Nature, at its most basic level, is a lefty. This was the first proof that the universe isn't perfectly symmetrical. It has a preference. This discovery led to the development of the Kaplan theorem. This theorem states that charge, parity, and time together must be conserved. If you change all three simultaneously, the universe remains the same. But here is the critical part. If parity is violated, as Wu proved, and charge parity, Cp, is also slightly violated, then time symmetry, T, must also be violated to keep the balance. This implies that at a fundamental, subatomic level, time itself has a built-in direction. It isn't just a psychological illusion or a byproduct of large-scale thermodynamics. It is baked into the fabric of the particles that build our reality. Now, let's bring it back to those asymmetric molecules. Scientists are starting to suspect that the reason life chose left-handed molecules isn't just a random fluke of evolution. Instead, it might be a direct reflection of this fundamental asymmetry in the laws of physics. The way subatomic particles interact, preferring one orientation over another, might have influenced the chemical soup of the early Earth, pushing life to adopt one specific handedness over billions of years. If this is true, then the arrow of time and the handedness of life are two sides of the same coin. The reason you experience a before and an after might be directly linked to the fact that your DNA spirals in a specific direction. We live in a universe that isn't balanced. It's slightly tilted, and it's that tilt that allows complexity to arise, for clocks to tick, and for memories to form. Without this molecular clutch grabbing onto the forward gear of time, the universe might just be a static, directionless void where nothing ever truly happens. Understanding the chirality of time changes how we view our place in the cosmos. We aren't just passengers in a neutral space. We are part of a massive, asymmetric flow. Every chemical reaction in your brain, every beat of your heart, is participating in this cosmic preference. We are biased toward the future because the very particles we are made of are biased toward a specific orientation. The past stays behind us because the universe itself has a left and a right, and it has chosen its path through the mirror. As we continue to explore the quantum world, the link between the very small, molecules, and the very large, the flow of time, becomes more apparent. We are searching for a theory of everything, but perhaps the secret isn't in a complex equation, but in a simple mirror. By looking at how nature breaks its own symmetry, we find the engine that drives existence forward, ensuring that the past remains a memory and the future remains a destination. For more incredible facts like this, don't forget to subscribe and turn on notifications.